Hello everyone and welcome to the webinar CrateDB in Azure IoT ecosystem. My name is Caroline Stewart. I work in the marketing team at Crate.io and I'll be the moderator for the webinar today. I'll just go through a few housekeeping things before we start. If you have any problems with the sound and you are having trouble hearing us, just let us know through the chat. If you can't see the screen share, again, please just let us know through the chat. And if you have any questions, then you can ask those through the presentation and we'll take those at the end. With that, I'd like to hand over to our presenter for today, and that is Tanay Pant. Thank you.
Thanks, Caroline. Hello, everyone. Welcome to today's webinar on CrateDB in Azure IoT ecosystem. I'm really excited to be amongst all of you. Today, we will talk about CrateDB, running CrateDB Cloud on Azure, launching a Crate cluster on Azure, delving into CrateDB for queries on some real-world machine data, CrateDB on IoT Edge, and finally, our licensing model. So let's get started. Yes, that's me. My name is Tanay Pant, and I currently work as a developer advocate at Crate.io. I'm also a tech speaker for Mozilla and volunteer to their various projects in my spare time. I'm an Intel software innovator in the field of IoT and have published books on Firefox OS, building a virtual assistant on Raspberry Pi, and web-based virtual reality. I would also like to take this opportunity to introduce you to Crate.io, the team behind CrateDB. We are a company of passionate, experienced developers who have crafted a bold and clever database for the fast, data-intensive world, making speed and scalability super simple, open, and accessible. A solution that's built to be sustainable for all. We have been working on developing technical architecture in IoT and time series field over the past 5 years. We have a co-selling agreement with Microsoft, and our client portfolio includes companies like McAfee, Nokia, Rauch, Alpla, and many more. So let's start off by going into the heart of the honeycomb, to the core technology, and talk about CrateDB and what makes it stand apart from the various other databases in this segment. CrateDB is a new kind of distributed SQL database that is best suited for handling industrial time series data due to its ease of use and ability to work with many terabytes of time series data with thousands of sensor data structures. CrateDB uniquely combines standard SQL with NoSQL benefits. It operates on a shared nothing architecture. CrateDB supports distributed SQL with full text search, geospatial data, and aggregations. Various nodes in a cluster coordinate seamlessly with each other, and the execution of write and query operations are automatically distributed across the nodes in the cluster. CrateDB has columnar caches for real-time in-memory SQL performance, and real-time databases usually require all the data to fit in the main memory. However, that limits how much data you can manage. Our solution for real-time performance without data volume limitations was to implement memory-resident columnar field caches on each node. The caches tell the query engine whether there are records on that node that meet the query criteria and where the records are located. And this all is performed at in-memory speed. Distributed query processing also contributes to fast performance and a query planner that makes very smart decisions about which nodes are best suited to perform different aggregations and joins. The storing and clustering has the benefits of NoSQL, and it has machine data specific features with cloud-native architecture, which allows it to run seamlessly on premises, edge, and the cloud. CrateDB delivers a substantial advantage in both cost and performance. Let's take a look at some of the salient features of CrateDB which makes it possible. CrateDB is simple to install. You can spawn an instance of CrateDB with a single line on your terminal or on Docker. CrateDB is ANSI SQL compatible, including joins and Postgres via protocol, which makes integration with tools such as Grafana easy and prevents lock-in. It has a distributed query engine which supports full text queries and is real-time. It supports all kinds of data, including structured, JSON, time series data, geospatial data, and even blob tables. It runs on commodity hardware and economical instances and is really easy to scale out. This architecture is well suited to containerization, meaning a cluster running on Kubernetes can be scaled up or down as easily as running a kubectl scale command. Scale-up operations can take minutes instead of weeks. Sharding, replication, and rebalancing of data as the cluster size changes are automated. These features prevent lock-in and allows you to interface with your favorite tools running wherever you prefer. Some customers report that CrateDB is 20 times faster than their previous database and on 75% less hardware. The motto of our company is put machine data to work. Every day, millions and billions of data points are generated by sensors, smart factories, health industry, mobiles, security applications, automotive and logistics industry. And all this data needs to be ingested in real time. And this data tends to be complex and can be in many different forms. This data also has valuable insights about the operation, which can be obtained from it by performing analytics on the data in real time. Queries like aggregation and time series analysis, along with machine learning or predictive analytical models, are often applied on this data. The insights produced by these analytical operations can be used to take action to improve the efficiency and functioning of these various industries, hence causing significant cost reductions. The differentiating factor as compared to other time series use cases that should be kept in mind is that these real-time queries are under highly concurrent load. For example, think of stream processing and machine learning and must access gigabytes to hundreds of terabytes of data. And it's a machine data world. In 2018, we saw a boom in the number of IoT devices and their use cases. There was an increase in the use of IoT and sensors in different contexts, such as smart factories and smart cities. The total number of IoT devices is moving towards 20 billion by the year 2020. And every second, another 127 devices are being connected to the internet. As an example, take a Boeing 787, which generates half a terabyte of data during a single flight. Machine data means explosive growth. In plastic manufacturing industry, there's a wide array of data being produced per bottle. And then there's data per production line with 10 production lines per plant. This data is being generated by around 950 sensor types. And that's just one factory. And this particular company has 180 factories in 45 different countries. This means data on billions of bottles. But we will talk more about this company and the data generated by it in a while. CrateDB excels at handling the velocity, volume, and diversity of huge industrial time series workloads. For example, industrial sensors often increase the frequency of their measurements when values exceed configured thresholds. With multiple sensors, cascading failures can result in huge data ingestion spikes. CrateDB is able to handle these spikes without sacrificing query performance, meaning that your reporting and analysis tools won't stop working just when you need them the most. This fire hose of complex data needs to be handled in real time. Let's now talk about the next layer of the honeycomb built on the core CrateDB technology, CrateDB Cloud, also known as CrateDB on Azure. CrateDB Cloud is a scalable SQL cloud service hosted on Azure and operated 24/7 by the experts at CrateIO. It is ideal for industrial time series data processing and other IoT and machine data analytic workloads. With 10 times better price to performance ratio than other time series cloud databases, unlimited scaling, plug and play Azure IoT integration, CrateDB makes it really easy and economical to build IoT systems on Azure. CrateDB Cloud is running on Kubernetes in different regions like Azure West Europe and Azure East US. Some of the salient features of CrateDB Cloud are: it has real-time query performance for partitioning, parallel processing, and in-memory columnar indexes, which enables real-time complex analytics and artificial intelligence, not just simple time series aggregates. It has Azure IoT integration via built-in interfaces to Azure IoT Hub, MQTT, Postgres via protocol, JDBC, REST, and a native .NET Core driver. It scales without limits with elastic scaling, partitioning, sharding, and replication for fast, always-on performance. It has elegant JSON handling and dynamic schema handling, and it automatically adapts schema to new JSON structures. It has a fully managed cloud service, which is secured, scaled, and operated 24/7 by CrateIO on Microsoft Azure. And of course, it is ANSI SQL compatible, making it easy to learn, use, and integrate. It causes no lock-in to proprietary time series data across different access interfaces. Let's take a closer look at where CrateDB fits in the Microsoft Azure IoT reference architecture. Let's start off by talking about hot storage. Hot storage is for data that sees continuous use and needs to be accessed immediately. For example, if you are collecting sensor data from machines on a factory floor, you want to be able to spot faults as soon as possible and act on that data right away. That means you need to pick a time series database that can handle the amount of data your sensors are producing, as well as offering real-time query facilities. Hot storage is the most expensive sort of storage because it typically involves the most performant hardware, advanced networking setups, redundant copies of data, multiple geographic availability zones, and so on. The Azure Reference Architecture uses Azure Stream Analytics and Azure Functions to handle hot path data ingestion, but those don't offer querying or visualization functionality. And if you want to do that, you can add Azure Time Series Insights to your tech stack. Azure TSI is good at what it does, but for the demanding workloads of industrial time series data, CrateDB has a much more competitive pricing structure than that of Azure TSI. We have seen a 10 times better price to performance ratio. Now let's talk about warm storage. Warm storage is for data that sees frequent use, and when small delays in access times for that data occur, they can be tolerated. That means lower infrastructure costs. The Azure Reference Architecture uses Cosmos DB for warm storage. Since CrateDB is a time series database, you have only one product to integrate with, as opposed to using both Cosmos for warm data and Azure TSI for hot data. Additionally, CrateDB may be a better alternative here because it is more cost efficient for extreme time series use cases. Cosmos DB can become expensive to run with large non-transactional workloads. Finally, let's talk about cold storage. Cold storage is for data that sees infrequent use, and when large delays in access times occur, that is fine. Typically, cold storage is used for historical data and batch processing, and is more common than real-time querying. This is the least expensive sort of data storage. Azure Blob Storage can archive data indefinitely at low cost and is recommended as the Azure Reference Architecture. CrateDB is also a suitable solution for cold storage, and we are constantly working on making it better. Now that we have an overview of how CrateDB fits into the Azure IoT reference architecture, let's take a look at how you can launch a cluster on CrateDB Cloud. So I will quickly spin up my terminal here, and I'll be using a command line tool called Crowd for that purpose. So it is a preview of what is going to be available for public soon. So you can install it with pip install Crowd. We have more information about Crowd in our documentation at CrateIO. By the way, if you're interested in playing around with it, you can reach out to us and we'll be happy to set you up. We'll share our emails in the last slide. So first of all, I will go ahead and log into the CrateDB Cloud portal with Crowd login. And this will spin up a login page. And the login is successful. I can return back to the terminal. So I will now quickly check which region I have set here with crowd config get region. And it shows that my region is currently set at West Europe, which is perfect. Now the structure of this looks something like the following. On the top, there is an organization which holds the various projects. Usually Crate creates the organization plans. So when I start the process to deploy the clusters, I already have an organization right now created for me called Azure IoT Webinar. So the first thing we have to do is create a project under this organization, and we will do that with the crowd projects command. So here we go, crowd projects. So we use the create command. We give it a name, let's say CrateDB Cloud Demo 2. And then we have to enter the organization ID. So as I mentioned, we already created organization for this, and I saved it in this Word document, and I will paste it here. So this will go ahead and create a project for me and give the ID of the project. And now I will deploy the cluster with crowd clusters command. So crowd clusters deploy. So I will give it the product name, and that is CrateDB.az1. And then I need to mention what kind of tier I want, which is extra small here. And then the unit of the cluster should be 1. So specifying unit as 1 basically spins off a 3-node cluster. Then here I need to give the project ID, which we just got in the previous step. So I'll copy and paste this. Now I need to give the cluster a name. So let's say the cluster name shall be cluster2. And I need to specify which version of CrateDB I want this to run. So I'll just say 3.2.6. And finally, I need to give it a username, which I'll say Tane, and a password, which let's say be crate hello 34. So what now it does, it behind the scenes, it starts the process to deploy this cluster. And it gives me information such as ID of the cluster, the fully qualified domain name, the name of the cluster, and the URL at which this cluster exists. So since it takes a while to deploy, I already created a cluster before this session. So let's see what it looks like. So this is the cloud interface, and here you can obtain more information about your organization, the projects within it, and the clusters that are within the projects. So this tab gives you an overview on the specs of your cluster. So we have the metrics tab after that, which shows basically the high-level metrics about your cluster. Then we have a logs tab, which is basically for logs which are automatically so this is for logs. And then we have snapshots, which are taken automatically every hour, and you can restore your cluster state to a previous state from here. So let's now take a look at the admin UI panel. Now this is the CrateDB admin UI panel. So in the front, we have information such as the health of the cluster, name of the records in it, and so on. Then we have a console to query the tables. And then we have a tables tab, which basically shows the tables that are present in the database and their characteristics, such as partitions, shards, schema, and many other things. So this data, this raw table, was basically generated from device simulation, which is a Microsoft IoT solution accelerator. So I just had to create an IoT hub, a storage account, and set up the simulator. I then connected the simulator to my cluster using the crowd consumers command, and this whole process took me less than 5 minutes. So in the accelerator, I selected a chiller device simulator with simulated data such as humidity, pressure, and temperature. So let's query this table and see what this data looks like. So as you can see, we have a timestamp and the timestamp of when this data was inserted into CrateDB. And we have data such as units of pressure, humidity, and temperature, and the different values that were created by the simulator. Then we also have a views tab here, a shards tab, and a cluster tab. So let's take a look at the cluster tab. As you can see here, we have a 3-node cluster since we specified the unit as 1 while giving the crowd clusters create command. And then we have a tab for monitoring and then a privileges tab. By the way, one cluster can also be connected to multiple IoT hubs, where a Crate cluster is ingesting data from multiple IoT hubs and multiple people are accessing the Crate cluster independently of each other. Well, let's return back. Now, if you think of it, Azure offers strong capabilities with different database offerings. But there is a gap when it comes to industrial scale use cases. Use cases where time series and relational data, real-time ad hoc queries, large data volumes, high ingest speed, high concurrency, multi-year retention, aggregations, SQL support, and capability of running on the edges required. Azure SQL is suited for transactional workloads and single-node time series use cases. Time series insights is a complete solution. However, it is more suitable for smaller scale and not for ad hoc or use cases which demand high concurrency. And then we have Cosmos DB, which handles data at large scale and is quite powerful. However, it's not built for huge machine data use cases. Hence, it becomes too costly in such situations. Finally, we have CrateDB filling in the gap and is suitable when unlimited scale is required for time series data with real-time SQL, cost-efficient architecture, and full edge support. Now, I would like to share with you a story of one of our customers named Alpla. Most of the people in the world use their products at least once a week, be it Coca-Cola, Head & Shoulders, or Dove. Alpla is well known in the consumer packaged goods market for its innovative packaging systems, bottles, closures, and injection molded parts, and we have been working with them for the past 3 years. They have sensors for temperature, pressure, blending ratios, and other settings that need to be very precise on every machine. When these settings are right, high quality products are the result. And when these settings are off, quality suffers and production costs increase. In the past, discovering issues required multiple people to be continuously moving around the factory, checking up on every single machine. As production lines are laid out over the whole factory, distances between machines can be considerable, meaning that this could be a slow and labor-intensive operation. Additionally, the latency introduced by having to walk around the factory meant that many products were often affected by a defect before the error was even spotted by an operator. So this resulted in the loss of valuable machine time and a loss of raw material as defective material gets produced till the problems are fixed. So Alpla's market entry in North America in 2001 was followed by years of tremendous growth. In 2015, it was already operating 14 manufacturing plants with more than 1,000 employees in the USA. With this growth came the challenge of hiring and training enough personnel to run the complex manufacturing processes. And because modern manufacturing machines each have a different sort of complex user interface, every plant required specially trained experts for every machine on every single shift. As a result of rapid growth, database performance degraded, and response time for queries got longer, and any analytics work on the data was taking more and more time. Real-time actionable guidance on the production floor was not possible. So CrateIO built their proof of concept on the top of CrateDB Cloud and enabled them to drive technological transformations. So we would like to share with you how the machine data from Alpla looks like, and then we can do some queries over this data. So I will pop in here and open the CrateDB admin UI for Alpla. And as you can see on the screen here, we have a lot of other applications running on top of CrateDB and utilizing the data from here. So it's open. As you can see here, we have a 5-node cluster holding about 2.8 billion records of data. So let's take a look at some of the tables and check what the data looks like. And we shall follow the flow of the data to understand how this whole system works. So I'm trying to come down here where the tables are named something like raw underscore bet1 or raw underscore bow1. So these are basically tables which hold raw data coming from a specific factory. So for example, this denotes the Bethlehem factory, this denotes the Florida factory, this denotes the Iowa factory, and so on. So let's open this raw underscore bet1 table. And so we just have 28.5 million records here. And if you take a look at the schema, we have only 4 columns. Timestamp, which is partitioned by month. We have timestamp, payload, and finally the topic. So let's query this table and see what the data looks like. So as you can see here, we have a payload which looks quite similar to a JSON object. And we have nested structures within it as well. And if you take a look at the path as well, you will notice that this has a meaning. And this means that this data is coming from a factory, which is the Bethlehem factory. And this record specifically came from production line 1. And then there's much more information about the specific machine this data is coming from. Now, if we were looking at the bottle underscore counts topic, let's take a look at some other topic. So here we have Soplar underscore measurements topic. So if you take a look at this topic and unnest the whole entry, you will realize that it looks quite different to the bottle underscore topics that we have above. And it's possible that different JSON structures are in a single column because of the dynamic objects data type in CrateDB. So once we have this raw data, it undergoes the enrichment process. During this enrichment process, the data is restructured and optimized for use and query operations. Context of the various sensors are also added to this data to make it much more complete. And since the data gets typed now, it is much more performant on CrateDB. And that is how we end up with the metric table. So here we have the metric table, which you see contains 1.3 billion rows of data. So let's query this table. And here we have this table. If you take a look at it, you will realize that we have a lot of columns here now. So what basically the enrichment module did, what it basically took out the different unstructured blobs of data, and it took the nested data and added it to a different column. And in case there isn't a reading for that, it adds a null value. And this doesn't affect the performance of CrateDB. So now that we have quite a lot of data, let's run some queries on this. So first of all, I would like to know the average of some of these values. And I prepared some queries beforehand, so we can just copy and paste them. All right. So here I want to find out the average of total in Delta in the O vision regex module column, where the type of the column's value is vision regex module. So we have this data running over 1.3 billion records, and we get an answer in just 4.4 seconds. Let's take another query. And since we were talking about smart factory use cases, let's add a query which is more relevant to this. So here in this query, I would like to know the unit and the message from the alarm and the machine it corresponds to, where the machine model is BMU200 and the type column's value is alarm. I also want the rows to be grouped and ordered. So let's run this query. And we have this query running over this huge data set, and we get the information that we wanted. And this query completes in just 1.3 seconds. Let's take another query. It's a slightly longer query this time. I'll copy and paste it again. So here, what I want to do is I want to obtain the production line from the location column, the downtime reason, when it started, when the downtime ended, how long it lasted, and finally, how old the downtime was. But I want to put in some conditions. The type should be downtime. The site in the location should be MCD, which basically refers to the McDonough plant. And start time should not be null. Reason for the downtime is cleaning of tool, and I want them in a descending timestamp. So here we have this data of when there was a cleaning of tool, when the downtime started, when it finished, how long did it last, and how old this particular entry is in hours. And this is a sub-second query, it takes us just 0.14 seconds. Let's take one last query. And I'll quickly copy and paste it from here. So here, what I want to do is I want to know about the field name from the parameter change column, model of the machine, and account of the occurrences in the last 90 days. And I have a long host of conditions here about which rows I want and which rows I do not want. So let's run this query. And it's running over 1.3 billion records of data, and it takes just 0.093 seconds. And here we have again a sub-second query. So let's take a look at the cluster here. So taking a look at the cluster, you will realize that it's only 5 commodity hardwares running on about 15 gigabytes of RAM and 8 CPU cores, and yet we are able to achieve high performance over 1.3 billion records of data. So every plant that was using CrateDB saw quite some improvements in their net equipment efficiency, with some having efficiencies above 90%. And every plant also saw a reduction in manual process adjustments by as much as 50%. So reducing the number of manual adjustments stabilizes the process and significantly improves the production efficiency. So the result was a six-figure saving in 2018. So currently there are about 2.5 million queries per day, and work hasn't even finished yet. It is estimated to increase about 18 times by the end of 2020. You can also take everything that we talked about and move it to the edge. And it is as simple as deploying a few modules on Azure IoT Edge. So let's take a look at CrateDB on Edge. So because of the sheer volume of data that is generated by these types of use cases, it is quite possible that at times customers like smart factories would like to store the data on edge for reducing network overhead and latency so as to take the actions with an even shorter turnaround time. So we recently collaborated on a demo which shows just how to do that. So this sample is hosted on GitHub under the Crate organization, and it shows how to store machine data from OPC UA servers locally in a single node CrateDB database. All the necessary components will be deployed by Azure IoT Edge, and we are using the following IoT modules in this demo. So first we have OPC UA server simulation module to simulate the data that will be generated, then OPC UA publisher module for publishing that data to other IoT Edge modules. We have a CrateDB module running CrateDB, a CrateDB saver module, which basically pushes the published data into CrateDB, an enrichment module that reads data from the raw table and writes it to the metric table, and finally, a Grafana module for visualization of this data. So you can use Vagrant to simulate an edge device. So first of all, the OPC UA data comes in, and it looks quite similar to the raw machine data that we saw earlier in iClass tables. The enrichment module then takes this data and enriches in a way very similar to what we talked about before. And then the enriched data is stored in a table, OPC data table. After that, we can visualize this data using the Grafana IoT Edge module. It's quite easy to connect CrateDB to Grafana because of the Postgres wire protocol. Now the time series data can be visualized on a dashboard in Grafana. Let's take a look at some of the licensing options for CrateDB. So first of all, we have CrateDB. CrateDB is the core database offering which can be deployed on-premise or on any cloud. It is licensed on the basis of a software subscription and can be deployed on a customer's existing Azure subscription. Example, bring your own license to a customer's Azure subscription. Furthermore, it is free if the deployment of CrateDB is limited to up to 3 instances. And then we have CrateDB Cloud. CrateDB Cloud is a managed security service offering directly from Crate.io, where the database is deployed and managed on the Crate Azure subscription on the behalf of a customer. So this is a bundled SaaS offering, often referred to as database as a service. CrateDB Cloud running on Crate.io Azure subscription is built directly with Crate.io. We manage the setup, sizing, and management of the cluster on your behalf. And something which is coming very soon is allocation of resources running in Crate.io subscription can be credited against customers' committed Azure revenue spend. And if CrateDB Cloud is running on the customer's Azure subscription, customers' transactions take place as they normally would with Microsoft for Azure consumption, and customer gets billed by Crate.io for management of the software in the customer's environment. With this, I would like to conclude today's XMark session on CrateDB in Azure IoT ecosystem. So today we learned about CrateDB, running CrateDB Cloud on Azure, launching a cluster on Azure, delving into CrateDB for queries on machine data, CrateDB on IoT Edge, and finally took a look at the licensing model. We are in the booming age of data, so why not put it to work to make our lives easier, safer, and better? I really look forward to seeing what you do with this. Thank you.
Thank you, Tanai. I'm now going to just open up the questions and see whether we've got any which have come through during the presentation. Just whilst I'm doing that, if you do have any questions once we've finished today, you can either email in directly to Tanai or you can email in to sales with the email addresses which are on the screen now. So I do see we've got a question here. I'll read it out to you. what is the core issue Crate.io is addressing, and what sets it apart from the other players in this market?
All right. So our three product streams, CrateDB, CrateDB Cloud, and CrateDB IoT data platform. So they enable the collection, analysis, storage, and provisioning of the data that is needed, both locally and in the cloud for smart factory and similar applications. So the core of the solution, as we talked about in the honeycomb structure, is CrateDB, which is a distributed SQL database and is really optimized for real-time industrial IoT requirements, including time series data management. So the database combines the familiarity and convenience of SQL with the flexibility and scalability of NoSQL. And the best thing is it enables the storage and processing of any structured and unstructured data type and the handling of large amounts of data in real time. And it also allows for unlimited scaling aligned with manufacturing growth. And then we have built on top of that CrateDB Cloud and leveraging the various other capabilities of CrateDB Cloud is Crate IoT data platform. I hope it answers your question.
Great, thank you. So there's another question here, which is, what industry or sector is Crate.io targeting the most?
Okay, so like we've been working since a while with a lot of industry projects. So building on that, working with these projects and the lessons that we learned from it and the different applications, Crate IoT data platform delivers an integrated solution for production companies with massive data volume. And with regards to specific requirements of discrete manufacturing in the use case that we saw with Alpha, CrateIO's solution provides functionality for device management, data enrichment, data science, including applications like AI and machine learning, dashboards, and notification and control in the production sector. So if you're more interested about the other characteristics of Crate IoT data platform, we have a really interesting blog post on our website written by Samuel. And if you have any other questions on this specific use case, I'd be really happy to just send me an email. I'd be happy to talk about that.
Great, thank you. So there's another one here. I'll just pull that up now. This is, I guess, two questions in one. What are a few of the most common challenges your customers are approaching you with? And are they replacing competitive solutions or more legacy ones?
Okay, so I think I'll split it into two answers. So I guess the first part was the common challenges that our customers approach with. So it's actually both the cases. Like when we are talking about CrateDB, CrateDB Cloud, data platform, these are actually often replacing legacy systems that were built and run by companies itself. So with a lot of time-consuming and complex support, there comes the issue of update and maintaining structure. So I guess that's one of the challenges our customers are approaching us with. And the second part of the question was, I think, replacing competitive solutions or more legacy ones. So the data ingestion capabilities of legacy systems and our competitive solutions aren't either comparable to CrateDB, and customers often use CrateDB to store and query machine data. So that's because CrateDB makes it really easy and economical to handle the velocity, volume, and diversity of machine and log data. And in fact, our customers have been reporting CrateDB ingesting millions of data points per second, and while they're simultaneously creating terabytes of data in real time. And some of the customers have reported 20 times faster performance than their previous database on 75% less database hardware. And if you're more interested in learning about these specific companies who have given us really interesting results and about their experience with CrateDB, we have a couple of case studies and white papers, I believe, on the website as well, which can give you much more deeper insight into these things.
Great, thank you. So I think we've probably got time for one more question. Is that all right with you?
Sure, of course.
Okay, so deploying new technologies to effect transformation usually begins with the transformation of existing beliefs and mindsets. How do you work with customers to help them understand how Crate.io modernizes their existing processes?
That's a really good question. So, Industry 4.0 has often been cited as the next revolution in industrial sector, with smart machines and intelligent services delivering productivity benefits to manufacturers. And a lot of these companies have struggled to capture and analyze the data produced by these machines in their factories. And the database infrastructure also has simultaneously limited these companies' ability to scale their facilities, because just there's a huge sheer volume of data, and like if you are not able to handle real-time actionable guidance by these systems, then that kind of creates a challenge, and especially when you're scaling these factories. So there are mainly three beliefs in this context of transformation that we try to transfer in our conversations with customers. The first is you need the ability to capture, process, and analyze massive quantities of machine data in real time. And if you can't, unfortunately, you'll always be one step behind your competitor. Second is, in order to make the decisions instantly and in real time, you need an instantly scalable solution capable of handling thousands of sensors across multiple production lines. And the infrastructure complexity and the amount of sensors in production facilities absolutely require a solid foundation. The time series database that you use must be like the air you breathe. I think our CTO says that, and it's a very, very fair thing to say in this, because the very basic thing that gives you everything that you need in order to survive, in this case, metaphorically, is air, but then it's the time series database. And then the third important aspect is you'll always need global connectivity and oversight to compare worldwide facilities. It's not only necessary for your production processes and improvement, but above all, it's important from a cybersecurity point of view. So you absolutely need a secure IT infrastructure to protect critical facilities. I hope that answers the question.
That's great, thank you. So I think that's pretty much all we've got time for today, but like we said, if you do want to ask further questions, please email into the addresses that are on the screen. This webinar has been recorded, so it will be available on our website, but we'll also send the link out to anybody who has attended, or if you didn't make it afterwards, that should be available within the next couple of days. So I just want to say thank you so much to Tanay for his presentation today, and wish you all a good day.